Alright, 10.1, number 16. Let me get the cursor out of the way. It says a bag contains 5 marbles that are each a different color. A marble is drawn, its color is recorded, and then the marble is placed back in the bag. The process is repeated until 30 marbles have been drawn. The table shows the results. For which marble is the experimental probability of drawing the marble the same as the theoretical probability? Then it gives us a value. Alright, well let's find the theoretical value first. Bag contains 5 marbles that are each a different color. Okay, so bag contains 5 marbles, they're each a different color. It doesn't really matter what the colors are yet. We just know there's 5 different ones. So if I reach into this bag and pull out a marble at random, it should be the chance of pulling out that specific marble, the theoretical prob, is going to be 1/5, right? 5 different colored marbles, I reach in there, I pull out one, I get 1/5, okay. And then we've got this table of experimental values. These are what they got. Okay, so we need to find the theoretical probability to match the experimental probability. Alright, well they drew these 30 times, right? So it's going to be one of these numbers, I'm going to call it x, over 30 needs to be equal to 1/5. And there's a couple different ways you could do this. So it's just saying the experimental probability has to be equal to our theoretical probability that was 1/5. Multiple ways you could do this. You could just plug in numbers and guess. I'm feeling a little squirrely today, so I'm going to solve it algebraically, because why not? To isolate x, to find one of these values, I'm just going to, well, multiply both sides by 30. I end up with x is equal to 30 over 5, which just equals, you tell me, that's going to equal some number, and that's going to match up with one of these numbers, and that is going to be our answer.